Hello everyone, my name is Soma Dinesh and I am from UEAT CSC branch. And today we are going to discuss about Spearman's rank correlation and let us see an example problem on it. Let us dive into the topic. Spearman rank correlation. Let us consider a group of n individuals and they may be arranged in order to merit with respect to some characteristics. Considering the orders corresponding to the characteristics of two groups, then the correlation between these pair of rank is rank correlation. And to calculate the Spearman's rank correlation, there are some formulae. There it is rho equals to 1 minus 6 sigma di square by n into n square minus 1. Here rho is the Spearman's rank correlation coefficient and di is the difference between the ranks and nr is the number of observations. And let us see some facts about the Spearman's rank correlation. Generally, the rho lies between -1 to +1. If rho is +1, then the complete agreement in order of ranks and direction of ranks is same. And if rho is -1, then the complete agreement in order of ranks and the direction of ranks is opposite. For suppose, let us consider if some of the observations have the same rank. In that case, we have to add the correction factor to calculate the Spearman's rank correlation coefficient. Here the correction factor is m into m square minus 1 by 12. This is known as a correction factor. Here we can see the new formula for rho adding with the correction factor. Like rho equals to 1 minus 6 of sigma di square plus 1 by 12 into m1 cube minus m1 plus 1 by 12 into m2 cube minus m2 by n square minus 1 into n. Here we can see that the 1 by 12 into m1 cube minus m1 and 1 by 12 into m2 cube minus m2 plus and so on. These are the correction factors. The number of correction factors will depend on the number of ranks that have become equal. And here the m1 represents the number of elements which have the same rank. Let us take example problem and so that we can understand more about this. A random sample of 12 father and their sons gave the following data about their heights in inches. Calculate Spearman's rank correlation coefficient. Here x represents the father heights and y represents the children heights. And we can see there are total 12 data regarding fathers and sons heights, and let us dive into the solution. Here first of all, let us write heights of the father in x column and heights of the sons in y column. And the capital X represents the ranks of the father's heights. Now let us rank them based on their heights. Here let us see what is the highest height of the fathers. You can see that 71. So we have given the rank 1 to it. And after that 70. So we have given the rank 2 to it. After that 69. So we have given the rank 3 to it. And after that 68 is the second highest, next highest rank, but there are two 68s. So in order to calculate that, we have to use the average system. Like see, for next ranks are 4 plus, comma 5. So 4 plus 5 by 2, so 4.5. So the 4.5 rank is given to both the 68s. Next we can see 67, but it also repeated 2 times. So we have to calculate the rank for them. Like next ranks are 6 plus 6 comma 7. So the average is 6 plus 7 by 2 equals to 6.5. So for the 67, 6.5 is given. And after that 66 is there, so it is given 8. And next 65 is there, so it is given 9. And 64 is there, so it is given 10. And 63 is there, so it is given 11. So in this way the ranks are distributed. Similarly, the capital Y, it is the ranks of the sun's heights is also written. Now di represents the difference between the rank x and y, like the ranks of x and ranks of y, and the di square is calculated based on the values, and the sum of the di squares is noted, like it is the sigma di square, which is equal to 70.5. Now let us find the solution. We have collected all the data required. Now here we can see several ranks have been become same. So we have to add the correction factors. Like the correction factor formula is m into m square minus 1 divided by 12. By using the formula, we have got 5 correction factors. The first correction factor is 0.5, second is 0.5, third is 5, fourth is 5, and fifth is 0.5. Like the 5 correction factors are like this. 1 is for 4.5 rank, and 2 is for 6.5 rank, and 3 is for 5.5 rank, and 4 is for 9.5 rank, and 5 is for 11.5 rank. This way the 5 correction factors have been came, and we have to substitute these in the formula for row. 1 minus 6 into 70.5 plus the correction factors. Here we have the 5 correction factors, and I have added up 5 of them by n into n square minus 1. Here n is the number of observations. We have 12 observations here. So 12 into 12 square minus 1, 144 minus 1, so 143. By calculating this, we will get 0.72. Therefore, the Spearman's rank correlation is 0.72. Thank you for giving me this opportunity.